Hello and welcome back to Cracking the Cryptic, and this is going out as I think we still expect Simon to be solving the live streamed Fistemafel, although he might have finished by now. This is going to be 2 hours after he started attempting it. I don't know if he's going to have got through. I think we were expecting it to be something like a 3-hour video. That's if he managed to solve it at all. So welcome if you've already seen the live stream. If you're watching this rather than the live stream, thank you so much. If you, I don't know, I mean, there are so many possible ways of doing it. Anyway, welcome to this video or whatever. We will be looking at an intriguing variant on Killer Sudoku in a minute. But as well as the live stream, we have, of course, got loads on Patreon, including the solve of the example puzzle for the live stream, which is using Fistemafel's Lighthouse rules and is by Fistemafel as well, a 6x6 version. That's proved quite popular. Lots of people have viewed that. Also proving popular, all our merchandise. I think this could be to do with the run up to Christmas, and we're getting a lot of orders. That's great. Thank you so much. There are some Christmas Sudokus involved and some classic phrases like knowledge bombs and bobbins, etc. from the channel. And of course, there's always the Discord server as well, which is linked under the video, along with this puzzle. This puzzle, oh, and our apps, SUDOKU PAD as well. Anyway, this puzzle's come in from Rodolphe Lepigre, and I think we solved one of his puzzles on Valentine's Day this year, so quite a while ago. But Rodolphe has sent something he calls a computer killer Sudoku. I think this is for programmers. And the reason is, if you look at the killer cage totals, you will see that they are not normal. Some of them are indeed quite implausible and apparently say 100 or 101 or F. And what you will realize if you're a computer programmer or someone who's dealt with bases is that these are not in base 10, or they're certainly, well, you will realize they're not necessarily in base 10, or all of them are not in base 10, but in fact none of them are in base 10. They are in bases 2, 8 or 16, binary, octal or hexadecimal, and it's up to the solver to work out which is which. So the way bases work, just in case you don't know that, is that the last digit of a number, let's take this number 100. The last digit adds the number of, in base 2, the last digit adds the number of ones, of units. We always start with a 1. The next digit adds the number of 2s, and the next digit adds the number of 2 times 2s is 4s. So that number in base 2 would mean the number 4. In base 16, it would be 0 1s, 0 16s, and 1 256. Which is 16 times 16. Now, we won't need 16 times 16 anywhere in this puzzle, because none of these cages are going to go up to 256. But we are going to have to work out what they are. So this 1, 1 cage, yeah, this could add up to 3 in base 2, being 1 plus 2, to 9 in base 8, being 1 plus 8, or to 17 in hexadecimal, being 1 plus 16. And all of those are possible. Now, the one thing you may need to be told is what F is doing in the puzzle. And what the F is doing is representing the number 15 in hexadecimal. So when you get into hexadecimal, after you've reached 9, after you've used 0, 1, 2, 3, 4, 5, 6, 7, 8, 9 as the units digit, you still haven't reached 10. That might be 10, which can add up to 16. So the numbers 10, 11, 12, 13, 14, and 15 are represented by A, B, C, D, E, and F. So that F, I think we can be very confident that is going to be 15 in hexadecimal. So there we go. Those are the rules. Normal Sudoku rules apply. Of course, none of these are in base 10. So none of them say what they look like they say. But do give it a try on the link under the video. I'm going to start now. Let's get cracking. And we're going to have to find cages where we know what base they're in. So this 100 and 101, let's mark binary in blue, B and B. Octal can be orange, but we don't have a color beginning with H. I suppose, what can we think of for that? Well, I'm going to just do green because it contrasts well with blue and orange. Anyway, I'm not sure. Those are clearly binary. This F is clearly hexadecimal. So we'll make it hedge green. There we go. Now what else do we know? Right, this 45, that can't be hex because 4 times 16 is 64. This would add up to 69. Now there is a secret that you need to know, that the numbers 1 to 9 add up to 45. So this box will add up to 45 because it'll contain each of the numbers 1 to 9 once. Now that means that this cage must add up to less than 45. 4, 5 cannot be a number in binary, so this is octal. So now we have some cages in each of the colors for definite. 1, actually, I don't know what base that is, and it doesn't really matter. In all of the bases, that is the number 1, so we can just enter that. 9 has to be in hex because the number 9 doesn't appear anywhere in octal or binary. Same with 18. Same with that 18. They have to be in hex. Now I should start working out what they add up to. And these two, that's quite interesting. Yes, 1, 0. Well, they can't be 16, so they must be 2 and 8. So they are binary and octal between them, and they are the digits 2 and 8. Now, where do we start? Okay, so this is octal. So 4 8s are 32, plus 5 is 37. So these digits add up to 8, which is not that helpful, because this 11 cage can be in any of the 3 bases. Okay, let's try this. This 1 8 is actually 24. So that's 9, 8, and 7. That's in hex. So this 17, well, it can't now be hex because that would add up to 23. Then these would add up to 47, and that would be -2. So this is octal. It's clearly not binary. So that represents 15, and that's the digits 1, 2, 3, 4, 5. So we get a 6 here. Now this 1, 1 cage can't now be binary, and it can't be hex, where that would have to be an 11 now. So this is octal 2, and we're adding up to 9, and that's a 3. These two digits added up to 8, so that's a 5. We can get rid of 3 and 5 from there. Now what's this 1, 1 cage here? Remember, 1, 1 adds up to either, I should probably memorize that because there's a lot of these, that adds up to either 3, 9, or 17. I don't think it can be 17 now. 9, 8, and 7 have gone. 6, 5, and 4, the next 3 highest digits, only add up to 15. So that's octal. It adds up to 9, and it doesn't use a 2 because they're confined in those cages. So this must be a 1, 3, 5 set. Yeah, that's right. So we've got a 2, 4, 6 triple at the top. Now this, this we know. That's 4 in binary. This adds up to 5, so it's either 4, 1 like that, or a 2, 3 pair. Now what about these? Yeah, one way to look at this is the 4 and the 2 units digits, they must represent themselves. So that's 6, and this cage is 5. So we're adding up to 11 in the units digits. Well, and the other ones for that. But then we've got these 2 1s to look at. Now they could be worth 8 and 8, 8 and 16, or 16 and 16. But we're adding them to the 11 that we've already reached so far. Now if they were 8 and 8, we'd only be up to 27. And subtract that from 45, this would have to be an 18. If they were 8 and 16, we're only adding up to 35 in these cells, and that would have to be a 10. So these are both hex. I can mark them both in green. This cage adds up to 20. This one adds up to 18. 38 and 5 there, 43. This is a 2. And now we know this is a 4-1 pair. That must be right. Those can't be 1, so we can fill in 1 here. What about this? I mean, the trouble is 20, I should have gone further in a way, but 20 and 18 are quite unhelpful numbers. I think there are various possibilities. This I'm moving on to. It's either 10 or 14. No, 10 or 18. It can't be 18. So that's octal and is 10. And it doesn't have a 4 or a 1 in it, so it's either 2-8 or 3-7. What about that? Obviously adds up to 9 in hex. This is either 8 or 16, so that could be either. This can't be 33 in hex, so it must be 17 in octal. Can't be binary because there's a 2 in it, so that's actually a 9-8 pair. That gives us this number. That's a 7. This F is 15, we said. Oh, and this isn't 14. This is 12 in octal. It can't be 20 in hex, so that's octal. 15 and 12 is 27. There are 2 ways to fill this. 7-8 there and 9-3 here, or 6-9 here. Oh, and 2 possibilities there. So this is either 7-8 or 6-9. So this one, this one can't be 9-8 or 7 now. So that's a 6 and that's a 9, and we're away now. 8 and 9. No, we're not away because this is either 7-5 or 8-4. It adds up to 12 under octal rules. Now this is a genuine 9 cage. Even though we don't have base 10 numbers, it's still worth 9 in base 16. And it doesn't have a 6 in it. Therefore, it's either 1-3-5 or 2-3-4, and it definitely has a 3 in it. Yeah, I don't know more than that. But it doesn't have 6 or 7 in it. So 6 and 7 are in these cells, and one of them's getting into this 1-0 cage, which can't be, well, it could still be 3 in binary. I hadn't thought of that. No, it can't be 3 in binary because this 9 cage needs a 1 or a 2. And it can't be 16. It can't be that anymore because we can't have a 9 in it. So this is octal as well. This adds up to 8. It doesn't have a 3. So it's either 1-7 or 2-6. This has the other of 1 or 2. It's either 3-2-4 or 1-3-5. That doesn't tell me what these are. Bother. Oh, that's not an 8, so that's not a 4. Okay, I'm not resolved there. Let's have a look up here. Now this could still be 2 and 1 equals 3. It could add up to 9 or it could add up to 17. So I don't know anything about that. This one either adds up to 9 or 16. And those are both still possible. Oh, 3-0. That's 24. That's 9-8-7 in octal. It can't be 48. And 3-0 doesn't make any sense in binary. Now, 1-3 here. Well, this can't be more than 11 now because we've used up 9, 8, and 7. So that's octal as well. That's a 6-5 pair. We've got 1, 2, 3, and 4 to place up here. Those can't be 4, those can't be 1, and that can't be 3. This can't be 4. Okay, back to this 9, 17, or 3. It can still be all of the above. So I just don't know what's going on there. Right, oh, 18, this is hex, so this adds up to 24. Ah, and the minimum numbers here, yes, are 8 and 7. And that would make 39, leaving 6 here, which would be 1, 2, 3. You can't go higher than the minimum numbers, or you're left with a smaller total than 6 here. Right, so that's 8 and 7. This is where 9 goes. And these are 1, 2, 3. So that is... oh, this can't be 3 either because of that set. So in fact, we know that the 3 is here. That can't be 3. We know where 3 goes in this cage. We're getting a lot of 3s done. And as I say that, it all peters out. 5, 6 pair means that can't be a 6. Now this, it can't be 1, 2 equals 3 anymore because of that. That wouldn't be able to be filled. It can still be 9, 8 equals 17. If it equaled 9, it can't be 5, 4 or 6, 3. Ah, I still don't know. It could be 1, 8, 2, 7 or 9, 8. Either way round, which is irritating. What am I missing here then? 7, 8, 1, 2, 3. These are from 4, 5, 6 and 9. This one can't be 6 or 9. So 4 and 5 must be down here somewhere. These are hard to determine. I'm really running out of cages to focus on. These are from 1, 7, 8 and 9. Are we getting any? If that was 9, 8. This... oh yeah, this could still be 1, 2 if that was 9, 8. Otherwise this adds up to 9. Oh, I'm wondering where 4 goes in this row. Can this be a 4? This couldn't be binary, and it couldn't be hex. And if it was octal, that would be a 5, which it can't be. So that's not a 4. So this is 4 in the row. Let's see if that helps anything. Doesn't look like it does much. This can still be a 2 if that's a 7. This is a very difficult cage to work out, actually. I'm quite amused by it. This can't be 2 or 4. Let's do that. And this can't be 1, 2, 8. 4 is in one of those 2 cells. 6 is in one of those. These others are 7 and 9. 5's in one of those. 3, 9, 6. Maybe I can work out what this is. If this is 2, 3, 4, then this is 1, 7, and this is a 5, 6 pair. And that does work. If this is 1, 3, 5, this is 6, 2. Let me just check. 2, 3, 4 makes that 7, 1. This is a 5, 6 pair. If that's 1, 3, 5, this is 6, 2. And then that's 7, 4. So this is either 7, 4 or 6, 5. Not 5, 5 there. 8, 9, 6, 7, 3. So that's a 4, 5 pair. So that can't be 4. This must be 1 or 2. This is surprisingly intricate. So that's a 1, 2 pair that I can't resolve. Okay, do I have to use these? I probably do. 1, 2 and 4. So these add up to 20 and 18. I hate having to keep doing these conversions all the time. Now, if the 18 had the 9 in it... this adds up to 20. And that, I think, might rule out this from being hex and 17, because that would be 9, 8. How could you make this 20 without using 9 or 8? You couldn't. 7, 6 and 5 only add up to 18. So that's not hex. It could still be binary or octal. So it's either a 1, 2 pair, which makes that 9, 8, or it adds up to 9. And we know those add up to 11. That's 20. These add up to 20 as well. That's 40. So these two add up to 5 to make up the 45 total for the column. So that's not a 5. Sorry, that one's not a 5. That's what I was trying to do. This also can't be a 4, so that can't be a 1. We're still not quite getting there. This is 2, 3, or 1 to make up that total. Sorry, I'm just still missing a trick here. 5, 4. What about this? It's not 3, 9, 6, or 1. Oh, look, 6 is looking up at that cell. Sorry, missed that on the old Stormtrooper scanning. 6 is down here with 9. This 4, 5 pair, which makes this 6 or 7. Whether that's 6 or 7, we use up 6 and 7 there. So that's not 7. And that's not 5. So this is a 4, 5 pair. So this is now in a 7, 8 pair there, which I could have worked out a different way. Oh, it's not giving up, is it? Is this, I mean, this is a huge difference between this being 1, 2 or adding up to 9. Why can't I work this out? 4 and 4, so one of those is 4. Oh, that's not 4. Is that interesting? Don't think so. If this was 1, 3, 5, that's 6, 2. One of these is 6. No, that doesn't get anything done. Okay, this is either, what is this? Okay, this is either a 1, 2 pair, or it adds up to 9. Oh, I decided that this added up to 5, but that was absolutely bogus. Because I don't know what this is, so that was silly, sorry. Let's get rid of those. Right, 11 there, 20 there, 31. Then this is either 3, making these two add up to 11, which would be very different, or it's 9, making these two add up to 5. So these two add up to 5 or 11. So I don't think I had the right to limit that top one at all. Can I prove 1, 2 wrong? 9, 8 would be there. That would be a 7. There's no problem with that. Can it not add up to 9? Then these two add up to 5, don't they? And whatever's in it, adding up to 9, is in these cells. I don't see how to use that. So I am very close to a finish here, and I'm not finding my way through, which is quite amusing. Oh, there must be a 4 in one of those two cells. That's not a 4. 6 and 9 are definitely used here. Oh, that doesn't make that a 6, 7, 9 triple, because that could be 5. 4, 1. Now, if that's 7, 3, we get 5, 6, 9. Right. If that's 7, 3, then this is a 7, 3, 5, 6, 9 quintuple, and that wouldn't have a fill. So that's a 2, 8 pair. Does that get me anywhere at all? This being a 2, 8 pair. 2, 8, 1. 8 is in a X-wing there. That's not very helpful. This could be a 3. This can only be a 3 if this is 3, 8, 9 adding up to the 20. If that's 3, 8, 9. That can be 2, 1. It doesn't really resolve anything. If that's a 3, we get a 5. Then this could be 6, 7, or 9. And they fit very well in a 20 sum. So, oh, Rodolfo, you've got me fooled here. I'm not sure what I'm supposed to be seeing or not seeing. This is clever. This is clever and it's very interesting. Right, 2, 8 are a pair there and a pair there. So one of these two is an 8. How about that? If that's an 8 in this 18 sum, then these two add up to 10. These two. And they couldn't be 8, 2, 4, 6, or 1, 9. So if that's an 8, this is a 7, 3 pair. That's a 5, 6, 9 triple. 7, 3 there. Oh my goodness, this doesn't work for a peculiar reason. If that's an 8, making this a 7, 3 pair, then these digits come from 4, 5, 6, and 9 because they can't be 7, 3 or 8, 2, 1. But that would make 5 digits in one box that would have to come from 4, 5, 6, 9, which is too many. Or put another way, this cell would have to be both 3 and 7 if they went in there. That's the simpler way. And if that was an 8, that would be 3, 7. So that is not an 8. That's the 8 in this 20 sum. These other two add up to 12. They can't be 7, 5 because this pair adds up to 11 and uses either 7 or 5. So that's 3 and 9 in those two. That's not 3. Right, this can still be 2, 1. If it adds up to 9, it's not 8, 1, 3, 6, or 4, 5. It's 2, 7. So it's always got a 2 in it. Whether it's 2, 1 or 2, 7, there's always a 2 in that. Therefore, there isn't a 2 here. And this isn't a 2, 1 cage in binary, therefore. There's no 2 there. This must be octal and adds up to 9. And then it's 8, 1. That can't be an... Why have I put... Did I use the base 10 numbers? Let's think about this again carefully. If this doesn't have a 2 in it, and it adds up to 9, can't add up to... Oh, it could still add up to 17. I don't know that it's octal. Right, but it doesn't have a 2 in it. Oh, it was never a binary contender. That was the problem. But it doesn't have a 2 in it. So it either adds up to 9 or 16. So it could be 9, 7. Actually, it could be that either way round, couldn't it? No, yes, yes, I don't know. It's either 9, 7 making 16, or it's 1, 8 making 9. If it's 9, 7, that's an 8. If it's 1, 8, that's a 9. That's just not a thrilling conclusion. And I don't know what it is. Right, 3, 8, 9 there. So we've got a 5, 6, 7 triple here, making 18, which is the right sum there. 3, 8, 9, come on. It is intriguing how much this can just confuse you because you're so used to denary base 10 values. So 9's not there. 9's in one of these two. So these aren't 9. That's been available for ages and I haven't seen it. So there's a 1, 7, 8 triple. So the 4 in this row goes there. These are from, well, not 2. 2 is confined to that cage. So the 2 in the row goes there. So these are 3, 5, and 6, which doesn't shape to help us very much. But that's 5 or 6, so this can't be a 6, 5 pair, adding to the 11 in those two. So that's 7 and 4, right. So that's 1 and 2, which is binary. That's not a 1, so these now have to be 9 and 7, making 16, because they can't have a 1 or a 2 in it to make 8. 7, 9, so this becomes an 8. These don't have an 8 in, so that becomes 8 in the top row. We get a 7 there. This doesn't have a 7 in or a 1. That is a 9. Right, we are cooking now, finally. 2 and 8, so I can actually resolve those colours. Those don't have a 2 in. Oh, come on, just keep going. 2 and 8, that wasn't the interesting part. That can't be 1, 2, or 4. That's a 5. So this now must be 5, 1, 3. That has to be right. 3 and 1 go there. This is 6, 2 as a pair. That's not a 6. That's not a 6. 6, 2 as a pair. That's not a 2. That's become a 5 because of the 4 we've placed. That's a 4, 6, 9 triple. 2, 8, 1. We've got 3, 5, and 7 to go in here. This has been a very, very surprising puzzle, holding me at bay much longer than I expected. That's not a 5. 1, 5, 6, 9, 4. So the only place, no, for 8 is one of those two. 6, 7, 9, triple. So that's a 3 and that's a 5. That's not a 9, that's a 6, 9 pair. This is where 4 is. 6, 7, 9, 1, 3. That's not a 3. 4, 5, 6, 7, 9. That's still not resolved. Oh, I can colour this for what it's worth. That's a hedge green hex cell. 16. 7, 9, 1, 2, 4, 3, 5, 6. This is a naked 8. 9 and 8. 9 and 7. That becomes a 5. Right, now I think we've got something going. This is 5. Yeah, 3 and 6. That's 6, has been for ages. Wow. 6. That is a 4 because it sees 1 and 5 now. So the central box is all done. 4 there. This 2 and 1 gets sorted. 1 there. 2, 3 pair. Oh, this cage. What does that have to add up to? It's octal, so that is an 8 to make 12. Yes, that's right. And that sorts out what looked for a moment like a deadly pattern. That can't be 3, so that's a 3. Now, we are very close. 1 and 7 can be done. 1 and 2 can be done. This 6, 7 pair. No, this 5, 7 pair. Then the 6, 7 pair. Then that 7 gets taken out of those. Something above must resolve. Yes, that becomes 6, 7, 9, 4. And there we go. What a clever puzzle that is. That really is quite interesting. Absolutely fascinating. I don't know if it's particularly more suitable for computer programmers. I really thought I would do a lot better with bases than take half an hour over that, but there we go. Do tell me the fast times you recorded and whether you think it helped if you were a programmer. I'd be fascinated, but thank you very much as always for watching, and indeed if you've watched Simon grappling with Fistemafel in the live stream, I'm sure it will have been entertaining. As it is, bye for now. See you later.